All right, guys. So, just a quick little heads up. Okay, obviously we don't have that long of a class today. So rather than doing your notes on Friday, we're going to do the notes today. If you want to do the homework, you can. But Friday, you won't have any notes. So if you want to just wait and do the homework on Friday, you could. Okay? But today we're going to do notes. And then Friday, you're going to do the homework that goes with these notes. Okay? All right, at the top. Okay, let's remind ourselves what we learned last week. Okay, you learned how to find holes in the graph. And remember that holes in the graph are going to come from terms that cancel out. Okay, so remember that if they're going to cancel out, they have to be on top and on bottom so that you can whoosh, whoosh, slash them out. Okay, vertical asymptotes. Okay, are created by leftovers in the bottom. And then zeros, or x-intercepts, as they're called in your notes, are leftovers on top. So holes cross out, VAs are left over on bottom, x-intercepts are leftovers on top. The last thing we added to your notes was horizontal asymptotes. And remember that horizontal asymptotes, I'm just going to abbreviate that, are where you follow the rules Bobo, Bot, and Betsy. Okay, that's where we'll follow Bobo, Bot, and Betsy. So, once you have that, let's go ahead and take a look at number one. The first thing you're always going to find is the horizontal asymptote. Okay, and the reason why is for the HA, you're doing Bobo, Bot, and Betsy. Okay, so look at this equation. Is it bigger on top, bigger on bottom, or are the top and the bottom both equal? Bobo. It is a Bobo. Very good, because it's an x squared versus an x3. So write down Bobo. And remember, what that stands for is bigger on bottom, the ends go to 0. So on your graph, I want you to draw a horizontal asymptote. Remember, that means that at the ends of the graph, it's going to flatten out towards a y value of 0. Okay, which will be basically right on top of the x-axis. Every other feature you have to factor to be able to find it. So for the top, we want to factor these. What could I do on top? Do you need a reminder of how to factor, or can you just tell me? Square roots, very good, perfect. Square roots. What's the square root of x squared? Okay, what's the square root of 16? 4. So it's going to go to x plus 4 and x minus 4. Okay, so the top was perfect square roots. Now, for the bottom, you're going to have to do grouping, and it's because it's 4 terms. So I know we haven't done grouping in a while. Okay, but let's review how to do it over here. Okay, so for grouping, you're going to underline the first 2 together and the last 2 together. So these guys are a group, and these guys are a group. Okay, out of the first 2, you're going to take out their GCF. So if it's an x3 and a 4x squared, what can I take out of both of those? X squared. Very good. Take the x squared out. And then what would be left over from the x3? X, and then the 4x squared would now just be a 4. Okay, then we go to our second group. I have a minus x and a minus 4. What can I take out of both? They really don't have a number in common, but do they both have a minus? So we'll take out a minus 1. Minus 1 comes out. Now my x is regular, and my -4, if I divide it by a -1, would go to a +4. Now remember, at this step, these have to match. If they don't match, that means that you messed up, but they do match, and that's good. So I'm going to put here, these have to be the same, and then I'm going to put a little check. Okay, remember, if those don't match, you messed up. If they do match, you have successfully factored by grouping. The little matchy factor is factor number 1. So it'd be the x plus 4. And then the other factor comes from the GCFs that you pulled out. So remember, I had pulled out an x squared from this group, a -1 from this group, then x squared minus 1 is the second factor. Okay? So the matchy factor is the first one, the GCFs are the second one. Now, if you look at the bottom, you should see that this can break down again via what method? This one can break down one more time. Perfect. Square roots. Very good. What's the square root of x squared? And then the square root of 1? Plus or minus 1. Now, just for a quick little recap here, how many factors or parentheses did I get on top? 2. How many did I get on bottom? 3 total. Does it make sense that this was a BOGO? Yeah, because it's bottom heavy, right? I got 3 x's on the bottom and I only had 2 on top. So that should also kind of confirm that it's a BOGO. All right, we're looking for holes. What's going to cross out? Okay, +4 is cross out, then where will the hole be in the graph? -4. Put x equals -4. -4 comma something. Vertical asymptotes come from x's left over on the bottom. Do you have any x's left over on the bottom? You have 2 of them, right? Then I'm going to have 2 vertical asymptotes. Remember, they're always at the opposite. So if it's a +1, that would be -1. And then I have a -1, that would go to a +1. Now remember, those are the x's that your graph, bless you, can't touch. So go into your graph and I want you to draw in asymptotes at 1 and -1. That's okay.
Notes from last class.
Y'all actually had a sub last class. Y'all didn't have any notes. So -1 here. This is what we're doing in class tomorrow.
Exciting.
Nope, you're good. And then +1 here. Okay, but remember, can't touch those lines. So 1 and -1, those are out. Are there any x's left over on top for my fraction? And if it's a -4, where's the x-intercept going to be? +4. So it'll be 4 comma something. Okay, then also remember that your y-intercept is always the 0 partner. So we're just going to look that up in the table. Okay, so I'm going to put always on that. Now, when I go into my calculator, make sure you're going to go into the y equals button, but you're only going to put the parts that don't cross out. So what am I going to type into the calculator on top? I still have an x -4, and on bottom, I have an x +1 and a -1. Okay, but the x +4s, those are gone. Those don't go into the calculator or else you're going to get a bunch of errors. Okay, so let's type it in. So y equals, open up your fraction. We want an x -4 on top, an x +1, and an x -1 on bottom. Okay, just like that. Okay, and then we're looking for the y values that go with those x values that we had already found. So I'm going to hit second table. And then I'm looking for 0's partner is 4. 4's partner is 0. And then -4, I'm pretty sure it's a fraction. Does anyone have it? -8/15. Thank you. All right, now remember, okay, the whole point of you finding those is so that you can graph it. So let's place these two first. So the x-intercept is 4, 0. That would be here. Give yourself a little dot. Okay, 4, 0. What's my y-intercept at? 0, 4. So that would be here. Okay, so a 4 on the x-axis, 4 on the y-axis. Okay, for the last ordered pair, if it's a fraction, okay, 8 over 15, if you don't know what that is, okay, you can divide it, but 8 divided by 15 is about negative 0.5, so that's about a half. So I'm going to put over here negative 4 comma negative 0.5. Now, it's not exactly 0.5, but that's close enough for us to graph it. So go to the left 4, 1, 2, 3, 4, and go down half a box. And then you're drawing a hole, not a point. That 1 pixel from the graph would be removed. Okay? Then from there, we're going to draw our graph. Now, these are going to be a little bit more complicated than the ones we did last time, but it's because you have 2 VAs. So just hit graph and it'll help you connect the dots. So I have my first piece in this corner. I have my other piece also in this corner. But then I have kind of like a little random quadratic looking thing in the middle. Okay, but the more vertical asymptotes you have, the more pieces that your graph is going to get chopped up into, because you can't touch multiple x's instead of just not touching one. Okay, overall, does that kind of make sense? Okay, so there is one more graphing question, but we're going to save that one for Friday as a warm-up. So if you'll just go to the last page. Okay. So we're saving question number 2 for Friday so that if you need a little refresher, you can do it. Okay, go to number 3. Okay, the other thing you're asked to do on this homework, and this part should be pretty easy, is that you're going to look at either a graph or information and you're going to write the equation. Okay, so on this graph, okay, look at the picture. Do you see a hole anywhere? Okay, at what x? -6. So if there is a hole at -6, what factor or parentheses would x have to be with? Remember, it's always the opposite. A +6, right? Now, if it's a hole, it has to cancel out. So here's my question. Where should the x +6 go in the equation? Should it go only on the top, only on the bottom, or would it have to go into both parts for it to be a hole? Both. So put an x +6 on top and an x +6 on bottom. Okay, holes have to go in both. Okay, next feature I'm looking for is x's that my graph can't touch. Do you see any x's where my graph gets broken up into pieces? There should be 2. -1 here I can't touch, and then 6 I can't touch. So put x equals -1 and 6. And where should those x's go in the equation? On the top or the bottom if they're vertical asymptotes? Bottom is correct. And if it's a -1, I'll put an x +1. If it's a +6, I'll put a -6. Okay, next thing I'm looking for are x-intercepts. Where does my graph cross the x-axis? Okay, 2 and -4. Very good. So I'll put 2 and -4. Where do those belong in the equation? Top, bottom, or both? X-intercepts only go on the top. So if it's a 2, I'd put an x -2. And then if it's a -4, I'd put an x +4. Okay, last question. Is there a horizontal asymptote where the ends flatten out towards? Okay, yes, at what y value? 3. So put y equals 3. And then, hang on one sec. Hello? Hi. I do have Moses. You going home? Okay, I'll send him down now. Thank you. Yes, sir. Bye. Moses, you're out of here. All right, now quick question. If I have the horizontal asymptote, does that mean that this would have had to follow Bobo, Botan, or Betsy? Bobo means it would have to flatten to what number? It has to be Betsy, because if it was a Bobo, it'd have to flatten to 0, right? So write Betsy. And now I want you to count the X's top and bottom. Do they both have the same number of X's? Yeah, because I have 1, 2, 3 on top, 1, 2, 3 on bottom. Then I need to pick numbers in the front that will divide to be 3. So I'm going to put 3 over 1. Okay, but as long as they divide to give me 3, that's good. Okay, but it would have to be a Betsy so that I can check that, like, I have the same number of X's top and bottom and they divide to the front. Okay? All right, 2 more left like that, almost done. Go down to number 4, put y equals big fraction. Okay, for this one, you don't have to look at the picture. They're just going to tell you what the stuff is. So I want a whole at what X? I want it at 3. Then what am I going to put for my factor? And top, bottom, or both? Wholes have to go in both. Because remember, how else are they going to cross out? They got to be in both spots. Okay, roots are the same thing as an x-intercept, in case you forgot that. Where do x-intercepts go, top or bottom? Top. And if I want it at -7, I'm going to put x plus 7. Okay, then you should remember that a multiplicity just means it's up there twice. So I'm going to put a squared on it to be lazy. Okay, but you could write the x plus 7 again. Vertical asymptotes, where do those go, top or bottom? On bottom. So if I want one at -4, 2, and 6, I'll put x plus 4, x minus 2, x minus 6. Okay, then it tells me that the horizontal asymptote needs to come out to 0. Does that make this a Bobo, a Botan, or a Betsy? In order for it to be 0, it would have to be a Bobo. Can you just count that there are more X's on the bottom? Okay, I have 4 on the bottom, but I only have 3 on top. Now remember, the reason I say 3 is this counts as 2. So this is 1, 2, 3 versus 4. Okay, so put a little check. All right, last one. Okay, we want to have a hole in the graph at 1. Where do those go? Top, bottom, or both? Both. And if it's at 1, I'll put x minus 1. Okay, for your roots to be at 0 and -8, my -8 is going to go to a +8. Do you remember how to get 0? Put just an x on the outside. So remember, a 0 means an x on the outside. Okay, it doesn't go into parentheses because it's with a 0 as its partner. Now, for the last 2 numbers, I want you to make them fractions. So let's put this one over 5, and let's put this one over 7. Okay, because on your homework, it does have some that are fractions. I want to make sure you remember how to do it. So if I want a vertical asymptote, I know that goes in the bottom. But if I want it to be 9 over 5, do you remember that you change the +9 to a -9? And then you slide the 5. Do you remember that? So if it's a fraction, it'd be x minus 9/5, but then you would slide the 5 so that it would go right there. Okay, then for my second one, it's a 6, 7. Okay, but it's a positive 6, 7. So we do -6, 7, and then slide the 7 to the front. I actually did that on accident. Not to be hilarious, but. Okay, so 7x minus 6. Okay, So if it's a fraction, just slide that bottom number to the front. Okay, then last thing, my horizontal asymptote's a 4. Is it a Bobo, Botan, or Betsy? Gotta be a Betsy. Do I have the same number of x's? Yes, then I need to pick numbers in the front that will divide to what? 4. So you could do 4/1. Okay, that would probably be the easiest, but you could put 40/10, 8/2 would divide to 4. You put whatever you want in the front as long as it divides to give you 4. Make sense? Okay, for your homework, okay, you still have 20 minutes. There are maybe 2 or 3 of these at the very bottom. You may want to just knock that part out and then save the graphing for Friday, but I'm going to let you decide that for yourself, okay? So you have about 20 minutes. And then remember Friday's pep rally day.
You know what day it is?
What day what is?
Birthday.
Wait, whose birthday? Happy birthday to you. Is it really your birthday? Wow! 17th?
Happy birthday, Joe. Joe, happy birthday, Joe.
It is Joe.
Yeah, thanks, guys.
It is your birthday. What are you gonna do? Celebrate?
I went to San Diego.
What did you do while you were there?
Everything. Well, my cousins are there. So
Did Mateo go? Just you.
yeah, it's me.
Find out.
Nice.
Get a seat my second.
Yeah, like.
Don't get a